effective size number and inbreeding coefficient are two extremely important parameters that we need to take into account while proceeding into selection, and even more important if we want to preserve a certain population. The correct calculation and tracking of these values have a direct effect on all the tools available in the breeding box, as we will see in the videos on variety improvement and breeding. This equation describes the most intuitive way to calculate effective size for our population, using the number of male and female parents randomly crossed at each cycle. As you can see in the table, the effective size is affected by two main components: the total number of parents and their sex ratio. For example, if we use a total of 1000 parents per generation, let them randomly pollinate, the effective size is 1000 if males and females are in a 1:1 sex ratio. On opposite, if sex ratio is 4:1, so we have 800 females and 200 males, the effective size is reduced to 640. The most extreme case, where we keep only one male to pollinate 999 females, the effective size drops to only 4. The effective size number has a direct effect on the average inbreeding coefficient calculated for the generated offspring. In that sense, the higher is the effective size, the lower is the average inbreeding of our population. The average inbreeding coefficient is sometimes multiplied by 100 and expressed as percentage. When our intention is to create several inbred lines, the number of parents used in each line is generally limited to few plants. If our intention is to rapidly increase the inbreeding coefficient of a line, we can use one male and one female, so it's possible to obtain up to 25% of inbreeding per generation. In some particular cases, the use of artificial sexual reversion for self-cross or chromosome doubling for creation of double haploid plants gives the possibility to increase even further the breeding percentage applied at each generation. The effective size calculation is also strongly affected by contraction in the size across generations. So, while proceeding for more cycles, the effective size number after n generations is calculated as the harmonic mean of the effective size of each cycle. Respect to the simple mean, a contraction in the effective size for a single generation has a more pronounced effect into the reduction of the effective size. In the example on the left, when there's no fluctuation of size number across 4 generations, the harmonic mean is actually equals to the mean. But in the example on the right, a contraction in effective size in one single generation drastically reduces effective size at 229 against a simple mean of 325. The effective size number calculation is also related to other two parameters: the unbalanced reproduction success, abbreviated as UR, and the pedigreed mating system, abbreviated as PM. When random mating and random seed sorting system take place, these are not possible to be controlled. On contrary, in a breeding facility, we have the possibility to manipulate the reproductive success of single plants present in our original population. Looking at this equation, for the unbalanced reproduction success, it's possible to reduce the variance in offspring production to 0 for males and females. The effective size from balanced reproduction can be up to the double of the effective size number. In the case our cross is perfectly balanced in the offspring production, it's possible to use the effective size number calculation for pedigreed mating population. Looking at these two equations, when the variance in the offspring production is 0 and the sex ratio of males and females is 1:1 are equal to 2 times the effective size number respect to random mating and sorting. Obviously, as we will see in a dedicated episode in the breeding chapter, changing to pedigreed mating system requires additional effort respect to random crossing, since it is necessary to create pedigree node for all the parents used in the crosses. But apart from this, switching to pedigreed mating system can artificially increase the effective size number is extremely important when breeding cannabis plant because some of the most interesting characteristics are expressed on female plants, and so unbalanced sex ratio is very often preferable. Why is effective size number and inbreeding coefficient calculation important? Because depending on the final goal of our project, is possible to set, during the preliminary planning phase, arbitrary threshold levels we want to gradually reach starting from our original population and for the several developing lines. The reported values are only indicative since each project can be different in terms of resources and final goals. When high level of inbreeding percentage are required, we are going to use few parents in each line following well-established inbreeding schemes. In this case, the inbreeding percentage of single plants used in the crosses must be calculated using path analysis and covariance table that we will see in a different video. The inbreeding percentage referred to a single plant rather than the average of a population is usually abbreviated with the letter F and expressed as a percentage. In this video, we have seen how to approach the selection of a population by tracking the effective size number and the average inbreeding coefficient. If you have any question, please leave a comment to the video, and for more content about inbred lines creation, check the breeding chapter for the last updated videos. See you! Ciao!